The relay that's on the development board can easily be controlled using the microcontroller. So let's take a look and see how that is done. So here we have the microcontroller, the development board, along with the microcontroller on board. And here's our relay. And off to the side there is a connection to the coil that's in the relay. Because if you remember, this relay contains a coil. Now I have in here as well a diode. That diode is to provide protection. It's a flyback diode for any counter EMF. So when the magnetic field collapses on this coil, that counter electromotive force is not going to go back and damage anything else. As a result of that, there is a specific polarity that we must observe here when making our connection. Without the diode, there would not be a need for any specific polarity. But because of that, the connection up at the top is for our positive, and at the bottom is our negative connection. Alright, so in order to control this relay, we simply have to provide a complete circuit. We've got to provide it because of the coil on here. It is designed for 5 volts, so we simply need to provide this with 5 volts and a ground connection. To control it with our microcontroller, you would think then we would simply take a wire from one of our ports and connect it to our positive, and take a wire, go from our negative and connect it over to one of our ground connections. Remember also that the first 4 on the left are our ground connections. The 4 to the right are our positive 5 volt connections. This would work with some devices, but for this particular relay and coil and microcontroller, this cannot provide enough current to drive this coil, this relay. Remember that a microcontroller is limited in how much it can source and how much it can sink. And in this example, we have it connected up for sourcing. The microcontroller needs to provide the necessary voltage and current to turn on the device. With this particular relay, this particular microcontroller, not enough current will be provided to energize it. So we cannot use this technique with this setup in order to make this relay work. So here's what we'll have to do instead. We will need to take and make a connection from our negative connection on a relay and take that to one of our ports, and then take the positive connection and go over to our plus 5 volts. And in this fashion, with this microcontroller, with this relay, this will work. The microcontroller can sink more than it can source. And so whenever we turn the port low, that makes the connection internally to ground. So we'll then have a complete path. We'll have our positive 5 volts. It'll go through our coil, out the other end of the coil, into that port, making the connection to ground. So this will work, this will serve to turn this relay on and off. In this particular example, when we have it sinking, a low is going to turn on the relay because we are sinking. When we use a high, when we cause that port to go high, that's when the relay will go off. Now that's not a big deal, but it can be counterintuitive for some people, and that can simply be compensated for or adjusted by the contacts that you use down below. On this particular relay, this connection is a common. This one to the immediate left is a normally closed, and the one on the far left is a normally open. To connect the device, we have to observe the current limits and the voltage limits and voltage types for this specific relay. This one can handle AC and DC. With the DC, it can handle up to 30 volts and 2 amps. So we can use any voltage that we want within that range. So let's say we have a motor. that motor would be connected to the common, and we would have our voltage source. Let's say it's a battery. Let's say it's a 9-volt battery. The other end then of this needs to get connected to one of our contacts. Let's say that we connect it to the normally open. In this particular configuration then, in order for this motor to go on, the relay would have to be energized, because whenever the relay is energized, the connection between the common and the normally open will be made, completing this part of the circuit. Motor would be turned on. Whenever the relay would go off, this connection would be broken. It would be open, because in this normal state, relay off, it would be open, and the motor would shut off. So if we have this configured for syncing, remember that a low turns the relay on. In this configuration, then, when it is a low, the relay is on, that would cause the motor to go on. So a low is turning on our motor. A high would shut the relay off, return to its normal state. That would make the motor go off. If what we wanted to do instead is have the high turn the motor on, we could take and use our normally closed contact, which is going to work just the opposite of the normally open. Let me redraw that. Let me just go straight across there. So now with a normally closed set of contacts, with this relay not being energized, this circuit will be completed between the common and the normally closed contact. Whenever we energize the relay, this connection will open. So now whenever we have a low, the relay goes on. That's going to change this from closed to an open. Our motor is off. So low, which turns the relay on, is going to go ahead and turn our motor off. If we give it a high, that turns the relay off. That restores this connection, because that's its normal state, it's closed, causing the motor to go on. So by using this syncing method, we might want to use the common and normally closed connection so that a high equates to the motor coming on, a low to the motor going off. Well, that concludes this video on how to connect devices and control the relay using the development board.